Welcome to calculus. You will master complex problems, but forget how to add. On this episode, Stevenson will demonstrate not all of our problems will actually have a context. For example, in this one, number 10, all the directions basically say is to use the given function to evaluate and find whatever is listed here. So this is the x value they want us to focus at. Here is the y function. And then in part A, it says find the slope of the curve. In part B, the equation of the tangent. And in part C, the equation of the normal. So when you don't have context like this, the only thing that's truly different is that you don't have units to worry about. Let's start with the first one. So we want the slope of the curve. So that means we're going to use our limit definition. We're looking at, this is my y value. I can think of that as my f of x, and my x specifically is 1. Let's go to the side and do our prep work before we rewrite our limit. Now that I have my two values, I'm going to take these two simplified expressions and plug them into my limit to rewrite it. Now we simplify by factoring out one single solitary h in the numerator. Now we can take our limits. What we just found, since we have no context, is we found the slope of this curve y at exactly x equals 1. That is part A. Part B says what's the equation of the tangent line? What are two things you need in order to write the equation of any line? You need a slope, and you need a point. Because it's the tangent line, that means you're going to always use the instantaneous rate of change at that value, which in this case is -2. The point we need to find. We know half of it. We know the x-coordinate is 1. So we need to figure out what is the other part of it. Remember, how would you find the y-coordinate if you know what the x-coordinate was? Wouldn't you just take that and plug it into the function? Well, in our limit definition, we do that. When we do f of a, we're evaluating our function at our particular value. So if we look at our work over here, f of 1 is just -3. So we actually found our y-coordinate for our point. So now we have the slope, we have our point, so now we can write our equation. Point-slope form is y minus y1 equaling the slope times the quantity of x minus x1. You can stop right there. The only time you ever need to simplify this is if it's a multiple choice question and the answers are in slope-intercept form. But you can stop right here. Question C. What is the equation of the normal? Well, remember, the relationship between a normal line and a tangent line is they are perpendicular. And remember, perpendicular means the slopes are opposite reciprocals. So, my new slope, if the slope of the tangent is -2, my new slope not only has to be positive, but has to be the reciprocal of 2. So that means it's going to be a positive 1/2. And again, I want the equation of a line. The point is exactly the same. What we have to do is write this same exact equation, except with the new slope.